20. A climate event that occurs when surface water in the eastern equatorial area of the Pacific Ocean becomes warmer than normal and may cause a warm, dry winter in New York State is. Now, this is kind of complicated. Usually teachers sort of go over this briefly. It's kind of it's complicated for kids. But just know anything that has to do with the Pacific Ocean near the equator, water changing temperature is either going to be let me go to this first. So what they're talking about is this general area here, Pacific Ocean near the equator. And sometimes they have these changes in water temperature, and the El Nino is when the water will be warmer than it normally is. And there's another event called La Nina, which when the water in this area is colder than normal. And actually, even though it's just over here, it can have great effects much further away, and North America can really experience it. So what they're referring to here, and I don't expect you to remember El Nino versus La Nina. You just recognize that when it talks about the Pacific Ocean near the equator, different changes in temperature affecting climate, it's going to be one of those two. And in this case, it's going to be choice number 3, an El Nino event. 21. In the New York State rock record, there is no bedrock from the Permian period, which 2 other entire geologic periods have no sediment or bedrock in the New York State rock record. Key point. No sediment or bedrock from those periods. You need to know to go to the reference table, centerfold, page 8 and 9, and this is where you need to look. So here we are on the centerfold, and where it shows New York State rock record is right here. And actually, I'm zooming in right now. It's right here. Okay? And if you look closely, at the top, it says New York rock record. This represents their sediment from that time frame, and the black represents that there is bedrock in New York State that was formed during that time. So let's look back at this. And the best thing to do is you need to look at your choices and then look at the reference table to see. So here we go. So the first choice is Cretaceous and Quaternary periods. I highlighted them in colors here. Are there any bedrock or sediment? Well, there's some sediment there, some sediment there. So we're looking for ones that have no sediment or rock record. These do, so it's not choice 1. Number 2, the Paleogene and Neogene. I highlighted those. They're here. Look over here. There is no bar here of sediment or rock, so it's probably that. It's probably choice 2, but this is an important test. Let's go through them all just to make sure. So Triassic and Jurassic is next. So Jurassic, Triassic. Look, there's some bedrock in New York State that spans both of those. So that does have rock from that time period. We're looking for them that have none, so that's not an answer. Choice 3. And then number 4, Mississippian and Pennsylvanian. Let's look at those. They are here, okay, Pennsylvania, Mississippian, and there's some bedrock in the Mississippian and some in the Pennsylvanian, so we're looking for some that have none. We're back to choice 2. Paleogene and Neogene periods is the answer for 21. 22. The cross-section below represents 2 widely separated bedrock outcrops. 1 and 2. Letters A, B, C, and D identify some rock layers. Line X, Y is a fault right there. The rock layers have not been overturned. Which lettered rock layer is the youngest? One of the key elements here is the oldest rocks are on the bottom and the youngest are at the top. As long as they haven't been overturned, most of the time, almost all of the time, they will give you rocks that have not been overturned. So oldest, and then they get piled up, and the most recent are at the top. So we are looking at which one is closest to the top. Now you can't just look at them because A and C look to be the same, and C is actually a little closer to the top. So we got to sort of correlate them or match them together. Usually the best way to do this is using index fossils, and that's usually what they'll have you do on this test, but not here. They don't give you that. So you're using solely rock types. So I'm going to match them up with colors. We're looking for the youngest here. So I'm using, so this is these symbols. You can look on the reference table on page 7 to show the sedimentary rock layers. Limestone, siltstone, shale, sandstone. So we're going to match up. I'm going to just kind of start at the bottom. B, what does it match up with here? Well, B matches up with this layer here. So this is limestone here. It's been broken by a fault. So those are the same basic age. They kind of form at the same time. We're kind of assuming here. We don't know for sure. And but those match up. And then on top of that, this layer here that is labeled C here and there's no label here, they probably match up. And because really what we're looking at, they're the same rock type, but really what we're looking at too is there's limestone below and then there's siltstone above for both. So they're probably the same age. And then what we're assuming here is that A, with this siltstone, with the shale below, that they match up. Therefore, the A is on top of the blue and C is the blue. Therefore, A must be the youngest, and therefore our answer here is choice 1. 23. The block diagram below represents the surface features in a landscape region. Which diagram best represents the general stream drainage pattern of this entire region? So this is what the land looks like. And then the choices are stream drainage patterns, which I'm going to put in here. So what would the stream look like if you look down overhead? What shape would the streams make? Now, there's a lot to this with the names of them, but we don't even need to know the names. Most of these questions that you will see on the Regents exam will just have you sort of match up, which is kind of nice because it's a bit just sort of common sense. I put this in a bit of one of the easier categories. It's nice to have some easier ones. So the water will all flow to the lower area. Notice these ridges of mountains. And hopefully you look at this and could recognize that the way the streams would probably form and the shape of them will be choice number 3. 24. It's one of those wordy questions. Just read it slowly, cross things out. Sometimes the words will just trip you up. I hate when I see that, but just read it carefully. Compared to a landscape that develops in a cool, dry climate, a landscape that develops in a warm, rainy climate will most likely weather and erode how? Faster or slower, and the landform is going to be more angular or rounded. So a little background here. So let's just talk solely about the amount of precipitation in the type of climate, wet or dry. Which will weather faster? The answer here is wet climates will have faster weathering because water is an essential element to weathering. Okay, so much of weathering is related to water, either chemically weathering the rock or physically taking it apart and physically weathering it. So that's key. Wet weathers faster. And then as far as temperature goes, cool versus warm, which will weather faster? And the answer is warm. Warm weathers faster, and you can really think chemical weathering here. Chemical reactions happen faster in higher temperatures. So with that, if you have warm and moist, you will have faster weathering. Okay, and what that leads to, in a dry climate, you may have, if you have flat rock layers, you may have this, and I call it to be much more angular. You're also, in a dry climate, not a lot of vegetation, so not a lot of that root action, and not a lot of soil being created, so it will look more like this, sort of more angular. In a wetter climate, it will look, you have more weathering, you have more vegetation, you have much more rounded landscape. Know that, that's key. So therefore, your answer to 24 is choice 4. You will, in a warm, rainy climate, the will weather and erode faster, so the landforms are more rounded. 25. Earth's crustal bedrock at the Mid-Atlantic Ridge is composed mostly of. You need to know to go to the reference table here. It is not expected that you know this. I guess it's expected. You need to know the Mid-Atlantic Ridge is on the ocean floor. You need to know that much of it. But you need to know when we're talking about this to go to page 10 of the reference table, okay? This chart right here, I'm going to zoom in right here. I'm going to zoom in a bit towards the top. And this is where it talks about density and rock type. I'm going to zoom in even further, okay? And what it tells you is the general density of continental crust is 2.7. So in general, it's 2.7 is the density of granitic continental crust. In general, continents are granite. And the ocean crust, the density is 3.0, and it's basalt. Okay, so it tells you that right there. Therefore, the answer to this question is choice 2. Basalt, density of 3.0. Question 26. This is an earthquake wave math question. Who out there likes earthquake wave math?
I do.
Great, one kid. All the internet, one kid. I know so many kids don't like this and have trouble with it. I get it. but you're going to get through it. Watch this. This is actually pretty convoluted too, but watch this, you'll get through it. A seismic recording station located 4,000 kilometers from the epicenter of an earthquake received the first P wave at 7:10 and 0 seconds p.m. Other information that could be determined from this recording was that the earthquake occurred at approximately, what time did the quake occur? And it talks about the S wave arrived at what time. So there's a lot to this, more so than the usual questions that kids don't like. But here we go. So I'm going to help you with this. You need this page of the reference table. I bet you're familiar with it. It is page 11, okay? Earthquake, P wave, and S wave travel time. So I'm going to zoom in a little bit. Please note travel time is in minutes. The thing that throws kids off sometimes is the epicenter distance, that's in 10 to the third kilometers. These are thousands, 4,000, 5,000 kilometers, 6,000, 7,000. So those are thousands down there. So that's important. So let's zoom in a little more. So this said in the question that it was 4,000 kilometers away, right? So that's 4,000, and then we're going to go, that is the line that represents sort of 4,000. And then we're going to see what that relates to the P wave travel time and the S wave travel time. So how long did, from when the earthquake happened, did it take the P wave to travel and arrive 4,000 kilometers away? What's the travel time? So you go up to the P wave and over, and that will give you 7 minutes even. So the P wave travel time, 7 minutes of travel time. That's key. The other thing you're going to need here, because it asks about the S wave, how long the S wave took, is travel up to the S wave. So you're going to go up to here, and then you're going to go over to here. And this is 12 minutes, and you probably have done this so much, you can remember that these go by 20 seconds, 20 seconds, 40 seconds, 60 seconds. So it's 12 minutes and 40 seconds of travel time for an S wave. Okay, so we're there. Now let's look at the choices itself, but it asks what time did the earthquake occur. So it's not just this. You have to then use this. So what time did the earthquake occur? Well, the P wave was received at 7:10, right? Received at 7:10 at this station 4,000 kilometers away, and it had been traveling for 7 minutes. So therefore, what's 7 minutes before that? Because the earthquake occurred 7 minutes before 7:10. Do that math, 7:10 minus 7 minutes is 7:03. So it occurred at 7:03 and 0 seconds, the time it occurred. But that's not all, because you look at the choices here. Well, first of all, it's kind of nice with this kind of stuff. 7:03, it's either 1 or 2. Cross out 3 or 4. Those aren't right now. It's asking the S wave arrived. At what time did the S wave arrive? Okay, so this is where if earthquake occurred at 7:03, and then it took the S wave 12 minutes and 40 seconds to travel to this seismic station 4,000 kilometers away. What time did it get there? So you have to add this to the 7:03, which is what this is. 7:03 plus 12 minutes and 40 seconds will give you 7:15 and 40 seconds. I bet that's one of the choices. And it is choice 2. 27. Which graph best represents the percentage by mass of elements of Earth's crust? Reference table. You got to know where to look. So first, looking for mass. Think mass, think weight, okay? That's what we're looking for. Not volume, mass in this case. So you got to remember that in your head. As you go to the front page of the reference table, and it's down here, it's down this section of the reference table here. Let's zoom in. It's this chart. And it has the chemical composition of Earth's crust, the hydrosphere, water, troposphere, atmosphere. So we're looking here at the crust. This is by mass, this is by volume. Volume is how much space it takes up. But again, the question, somebody's that asks those questions by volume, always make sure you're in the right column. This is really what they're testing here. And this is the mass column. And you can see oxygen to silicon, it gives you the percentages. Once you get there and then you look at your choices, which is a pie graph, you then end up with choice 1 being your answer based on that page of the reference table. 28, glacier question. The aerial photograph below shows an elongated hill near the Finger Lakes formed by glacial deposition in New York State. There's a picture of it there. This is one of those, shows you this picture, you just got to know the term for it. And sometimes that can be tricky because kids don't commit them to memory. So let's just go into this a bit. Here's some other examples of it here. This is another diagram from another region showing what they are. And these are drumlins, these are elongated hills. It shows the glacier kind of moved this way. In this case, definitely not this way. Maybe this picture will show it better. In this case, this is sort of from the area. Direction of the glacier moved this way. You know, definitely not this way because it kind of stretches out these hills as it goes over it. Here's actually that picture color in the real world, that same picture they got from the test. And the glacial movement is this way. And maybe, you know, it could be this way. It's definitely not this way. It didn't run over a pile and, you know, going this way. It wouldn't stretch it out in this direction. Here are some pictures from Canada, I believe. See some drumlins in here. It's cool because, you know, I like drumlins. Some more pictures here of drumlins. Guess what the answer is? It's 4, drumlin. 29, the photograph below shows a valley glacier altering the landscape. The result of this glacial action will be, so it's asking, what shape the valley going to be? U-shaped or V-shaped? And then what the bedrock's going to look like? Well, so let's go into this a bit. So some things that are key. Here's a close-up of it. The picture's probably not going to help you too much. You got to kind of know this. Glacier forms a U-shaped valley. I got some real photos of the real world here. That is key. Glacier forms a U-shaped valley. You really see it here. It has so much erosional force that it leaves a valley shaped like that. Here's another. Oh, this is a good. Come on, look at this thing. So good. U-shaped valley, glacier. Look at that thing. It's awesome. Right? Glacier U-shaped valley. Know it. Comparatively, a river forms a V-shaped valley with the downcutting of the river. River V-shaped valley. How on earth am I ever going to remember that? You're thinking, there's no way on earth I can never remember that. Never, ever. Or, look, river has a V, V-shaped valley has a V. You got it? See what you did there? All right, come on. So know that. River, V-shaped valley, glacier, U-shaped valley, it comes up. Another one, look at the V-shaped valley, river. God, I love it. Look at it. So V-shaped. Great. Now, to show what the bedrock's going to look like of a glacier, we got more. Look, I'm comparing them next side by side. Glacier, U-shaped valley, river, V-shaped valley. Know it. Now we're going to do the bedrock maybe. I'm going to show this video I took in Socrates of bedrock by a glacier. Check it out. Dude, how cool is that? Was that cool or what? That shows that the bedrock that gets eroded by a glacier, the rocks that are frozen at the bottom of the glacier will actually scratch grooves into the bedrock below. Super cool. So know that the bedrock that has experienced glacial erosion will often have parallel scratches and grooves, striations. They're called striations usually, and therefore the answer here to number 29 is 1. 30. Which element is always found in bioclastic sedimentary rocks? Not expected to know it, expected to know how to find it in the reference table. Key thing, what does bioclastic mean? Well, bio, prefix means life, clastic means fragmental, pieces of, broken pieces of. So a bioclastic rock is broken pieces of a thing that was formerly living. Think of broken up seashells, clamshells that are cemented together, or pieces of dead plant life that then becomes lithified into a rock like coal. So, but what we need to do here is find out what is the main element that makes them up. Let's go to the reference table, and this is page number 7 of the reference table, sedimentary rocks. And you have to look around for bioclastic. So look around for bioclastic rocks, and you're going to find it there. So the main type of bioclastic rock, actually here, bioclastic, and this is also bioclastic. So it's these two. It's the limestone or bituminous coal. And what we're going to do, this section of the reference table, let's zoom it in, make it bigger magically like that. And so bioclastic. The composition of it is carbon, the element carbon. I hope that's a choice, man. I hope that's a choice, man. Choice 3. 31. What are two major factors that control the development of soil in a given location? So let's talk about soil a little bit. The components, what makes up soil, weathered rocks, they have bedrock that gets broken down into things like sand, silt, clay. And then the other portion of it is organic matter. Think of dead leaves, worm poop, etc. That combines to make soil. So what are some factors? Knowing this, what are some things that are most going to control the development of soil? So the answer here is going to be bedrock composition and climate, because the type of bedrock that's there is going to depend on how fast it weathers, and it leads to what type of soil you're going to get. And the climate also will have a big effect really of the organic matter that's going to be there. If it's really dry and really hot, you don't have a lot of life. If it has a lot of rain, right, most things like plants and animals need that water. So the more water there is, the more biologic activity and the more soil is going to form. So choice 4. 32. The cross-section below represents rock units within Earth's crust. The geologic ages of 2 of the layers are shown. Really, the periods that they formed are. So the Cambrian and the Silurian. Which sequence of geologic events occurred after the formation of the Cambrian limestone and before the Silurian limestone? Okay, so what they're asking is like, yeah, what happened in between here that caused this layer here? So what this is, that I highlighted it in red, is this is called an unconformity, because these layers here don't conform to this. You notice how they're all on top of each other, and they all have the same shape of the folding here, and these are really flat. So these layers do not conform to the layers below. Now, what could cause that? Because if you think back to geologic history, all these are sedimentary rocks deposited flat on the ocean floor, and they will often be flat like layers of a book, oldest on the bottom, youngest on the top. What happens to this? This creates a gap in time. So let's look at this. Again, unconformity, another word for it is buried erosional surface. Well, what's going to cause all that erosion? Just to go back here, one thing you got to point out is that above this Cambrian, there probably was hundreds of feet of rock above it that are no longer there, okay? But so you got to keep that in your mind, that that was there. What would cause them to not be there now? And then I want to throw out the word subsidence, or think of subside, means the land surface sinking below the sea level, because that's one of the things that we're going to need to know for this. So, one of the things you want to think about is, just because you see this here, this land over millions of years, it's hard for us to wrap our brain around. It gets pushed up because of plate tectonics, it gets pushed down, it gets faulted, it gets tilted, it gets folded like this. So this has undergone in the past a lot of different changes that maybe is hard for us to really think about. But so what happened between Cambrian and Silurian? So this rock was all flat on the ocean floor. Then somehow it got pushed together. It got folded like this. Again, there was a lot more layers on top. And this all gets deposited under the ocean. Now, erosion really happens above the ocean surface. Below the ocean deposition, above is where it gets exposed to the elements, and it gets weathered and eroded. So this was underneath the ocean. It got lifted up above the surface. Erosion happened, probably hundreds, maybe thousands of feet of rock got eroded, weathered and eroded off slowly. Then it all ended up back down below sea level. Maybe sea level rose, or maybe the land subsided, subsidence below, or a combination of the two. So that back under the ocean, the Silurian limestone and then this layer of shale could be deposited on top of it. Which choice is that? Number 1, uplift, pushed above the surface, then weathering, erosion, subsidence. Choice number 1. 33. Which 2 rocks contain the mineral quartz? Reference table, reference table. Here we go. Most of these are igneous rocks, so let's start there. So igneous rock, page 6 of the reference table. I highlighted some of the choices there. Pumice, granite, scoria, gabbro, dunite. Those are some of the rocks in the choices. So this is all work that you need to do. Now, these names here all, to know what minerals they're made up, is you follow them down here, okay? You probably have seen this before. So granite is made of these minerals here. Granite does not have any olivine in it. Granite does not have any pyroxene in it. So the only rocks on this case that I've highlighted that are going to have some quartz in it will be the ones that are directly above it. So granite has quartz in it. Pumice has quartz in it because it goes straight down. Scoria, gabbro, no quartz because the quartz is over here. Dunite, even further from quartz. So these don't have any quartz in those rocks. So if you go back to your choices, you got to kind of cross them out. Which two rocks contain mineral quartz? I said, well, gabbro doesn't, so I don't need to look at schist. Gabbro doesn't. Dunite doesn't either. Cross that out. Granite does. We'll see if gneiss does. Oh, and pumice does too. So it's one of these two. So now we have to, oh, actually, you know what? Scoria doesn't. Scoria, if we go back, where's scoria? Scoria does not have any, so that crosses that out. Even see, it kind of tricked me there. I even did this. So the scoria eliminates that. But I like to double check because we do have sort of one answer. And let's check to make sure that gneiss does. Now, gneiss, hopefully you recognize, is a metamorphic rock. If not, look around for it. It's on the next page of the reference table, page 7, at the bottom. Where is gneiss? It's right there, okay? So what we're going to do, here is gneiss here. This is the composition. So now you follow it. This is the minerals that make it up. So for instance, slate, what makes up slate? Just the mineral mica. But these, phyllite here contains garnet, amphibole, feldspar, quartz, mica, but no pyroxene. Gneiss, go over here. Does gneiss contain quartz? Quartz is right there. Yes, it does. Therefore, that sort of solidifies my answer because both of those rocks, granite and gneiss, contain quartz. Choice 3. 34. Which chemical formula represents the composition of a mineral that usually exhibits fracture, not cleavage? I bet you don't have the chemical formulas of these minerals memorized. You laugh. I did. In college, I had all these memorized. I was good with this. Not so much anymore. The crew's laughing in the back, but I did. For you, it's a reference table. Here we go. It's the back page, the mineral page. First, what are we talking about? Oh, which one is fracture, not cleavage? Doesn't really pertain to the question, but a little brushing up will help. Fracture breaks with irregular surfaces or no pattern or order to the breakage of it. Conversely, cleavage breaks with a pattern or order. It has maybe has some flat sides, some geometric shapes, and that's how they differ. But for this, we're just looking at the chart. Too much earth science is about stupid charts. This stuff's way cooler. But anyway, so on the back page, this is the chart. This is the cleavage of fracture with check marks. On the left, if it's checked on the left, that mineral has cleavage. If it's on the right, it has fracture. And then here is the chemical composition is here. So it doesn't give you the names, it gives you the composition just to see, can you look stuff up in a chart? Okay. And so what you want to do is then go find these. You got to look through and find the formulas here. I've highlighted them. So these are the chemical of your choices based on the composition. And then you want to see which one, it's going to be one that has fracture and not cleavage. Okay, cleavage, cleavage, cleavage. This one has fracture. What's that? Olivine. But as a matter of fact, the choice is going to be this chemical formula, which is choice number 4. 35. Which mineral is commonly used as the lead in pencils? And there are your choices. So you got to go to the mineral chart of the reference table and look under uses. As long as you know that it's there, you're cool. So here's the mineral chart. It's the back page of the reference table 16. Where's the uses column? Is right there. Okay, and you got to kind of just look around. As a matter of fact, I would just look for those 4 choices. Look at the minerals that are your 4 choices. And what you're going to see is uses right to the top. Pencil lead is the first one. Therefore, that's graphite. So the lead in your pencil, not lead, is actually made of carbon, but it is graphite. Therefore, that is choice number 2. 36. We're now on to part B-1. All this stuff up here, geez, I know all you teach you goes, read the directions. So important to read the directions. Who likes reading directions out there? Yeah, no one. You don't. I know. I don't like to either. Okay, so I'm not going to be such a stickler. Some of this stuff here is boring. For each state, the question, reference table is kind of boring. And this stuff here, I'm not going to say it's the most important stuff in the world. but you should read it anyway. Sometimes there's stuff in there that's important, okay? I don't like reading directions either. I don't love directions. Okay, my wife loves directions. I don't love directions. She does. She loves reading the directions. But anyway, read the directions because sometimes there's a little nugget in there that will really help you. You have time on this test. Don't be in a rush. Read the directions. Okay, it's a necessary evil. So here you go. Base your answers to questions 36 and 37 on the graph below and on your knowledge of earth science. I'm almost falling asleep as it is. The graph shows changing ocean water levels over a 3-day period at a shoreline location, Kings Point, New York, and Long Island. I don't think anything that really is going to help you with this. So here we go. The question 36, here's the chart. Based on the graph, the first low tide on December 26th occurred at approximately, so you want to think, let's go to December 26th, and you go, oh man, December 26th isn't even on the chart. It's the 23rd, 24th, and 25th. What they expect you to do here is to use this, because it's a cyclical, it occurs over and over, use the pattern of the previous days to predict when it's going to happen on the 26th. So the first low tide, so the low tide is going to be the bottom part where the water's lower. So you see the first part of the day. So this is midnight. The first part, December 25th, it's around a little before 6 a.m. What are these? Whatever these count by. They count by 2, 4. They count by 2 hours. So it's probably 5 a.m. Here's about 5 a.m. No, that's p.m. On this day, it's about 4 a.m. So maybe around 4, 5 a.m. And the best answer here is actually going to be choice 1, 6 a.m. And you can see the pattern here because on this one, it's maybe around 3 a.m. and then it's 4 a.m. and then it's 5 a.m. So it's going 1 hour every day, which is what the tides do. So 6 a.m. is the best answer, 36. 37. These Long Island tides show a pattern that is cyclic and predictable, cyclic and unpredictable, non-cyclic and predictable. First of all, let's, the word cyclic or cyclic means that it occurs in a cycle. It has a repeating pattern, right? A cycle, think of it going around, it repeats itself again. And the other thing you have to know about tides is that it is a function of the moon going around Earth, and it is very predictable because the moon's orbit is predictable and it's very, consistent and happens again and again. Therefore, the answer is cyclic and predictable, which is a lot of things that earth science are, but definitely tides are. So that's one of the things you just kind of need to know. In case you missed question 36, I talked about reading the directions here. I don't like reading directions either. You should read them. They're not just, some of them are just like nothing, but sometimes there's little bits in there that will help you, or you need to know. A lot of times it's just a bunch of nonsense, but read them anyway. Know that it's just this chore. So, basic answers to questions 38 through 41, diagram below, knowledge of Earth, diagram represents Earth's orbiting the Sun, 4 positions of Earth in the orbit A, B, and C. Letter N represents the North Pole. Distances are indicated for aphelion, Earth's farthest position. Oh, that may be important. Aphelion, Earth's farthest position from the Sun, and perihelion, Earth's closest position around the Sun. That's one of those where this can help you because most people don't have that memorized. So, the question is this for 38. During which season in the Northern Hemisphere is Earth at aphelion? So, you can tell, well, what's aphelion here? Aphelion, and from the part of the directions, it's when Earth is farthest from the Sun, perihelion closest to the Sun. So which one's farthest? Well, when it's right here. So this is C is in this. So, but what season is it? So you know something about seasons. So look at the orientation of Earth and its axis to the Sun, because you need to know this. You need to apply some seasonal knowledge here. And in this case, look at the axis. This is going to be summer. By summer, I mean summer for us in the Northern Hemisphere. Well, it's summer for us, winter in the Southern Hemisphere, but we're talking about us in the Northern Hemisphere. And this is winter. Look, axis tilted away is winter. The North Pole tilted toward is summer. Here's a close-up of it. So when the North Pole is tilted away from the Sun, if the Sun is over there, North Pole is tilted away, that's going to be winter. The sunlight won't be as strong and causes it to be winter, as opposed to summer. In this case, the sun's coming this way. North Pole tilted towards, it makes the sun be stronger, we get more heat from the sun. Therefore, what you want to do going back to this, North Pole tilted towards the sun at have feeling in what season is it, and it's going to be summer. Okay, I think some kids get tricked because they go, "You're further away. It's got to be colder. It's got to be winter." That's wrong. Okay, if you think that, now's the time to stop thinking that. It's all about the tilt of the axis. 39. This is a tough one, I think. Between which pair of letter positions is the sun's vertical ray moving from the equator southward to the Tropic of Capricorn? Now, I don't expect you to know what the Tropic of Capricorn is. You can look it up on the reference table. But I think the key thing here is that it says southward. So the vertical rays is moving, they're moving from the equator south. Now, if that jumps out in your brain, that's great. But if not, basically, I'm going to point this out. This is the vertical ray right here. And on this particular day, the vertical ray is on the Tropic of Cancer, which is in the northern hemisphere, 23.5 degrees north. And notice, back to the seasons, the North Pole tilted towards the sun. This is the first day of summer, June 21st, for us in the northern hemisphere. Okay, this is not what they're referring to. I'm also going to point out that the sun is directly at the equator on the equinoxes, okay? March 21st, September 23rd, that's when it's there. So it's moving from there to the Tropic of Capricorn. Here's a photo, but this changes a bit. The sun's coming this way. The vertical rays at the Tropic of Capricorn, this will be the first day of winter for us, December 21st. For us, again, for them down in the southern hemisphere, it's their first day of summer. So this is where it gets really sort of complicated. You have to know a lot of these things. Notice December 21st, North Pole tilted away from the sun. That's how we know it's the first day of winter. So you have to apply that to come up with between which two seasons. So I guess you have to realize it's going to be, one of them is going to be winter. It's going to be from fall, from September to December. Okay, so the winter, this is the first day of winter, North Pole tilted away from the sun. Okay, so it's going to be D and A, or A, yeah, D and A is going to be the answer. That is a tricky one. 40. Approximately how many times does Earth rotate as it moves in its orbit from position A back to position A? So from A all the way around the sun there. How many times does it rotate, meaning complete full rotation? I think you just kind of need to know that one full rotation is one day. Okay, that's what they're getting at here. So it's basically how many days or how many times does Earth rotate? How many days does it take for Earth to go from A all the way around back to A? Answer is 365 days in a year. That's what defines a year, how long it takes for the planet to go once around the sun. 41. What is the tilt of Earth's rotational axis relative to a line perpendicular to the plane of Earth's orbit? Basically what they're asking is, what is the tilt of Earth's axis? Okay, that's basically it. There's a lot of words in there. So here's a diagram. If this is Earth's orbital plane right here, shown by this gray, it shows the axis and how it is tilted from the straight up and down position. It is 23.5 degrees tilted like this. That is a number you should commit to memory. It's not in the reference table anywhere. 23.5 degrees. That question comes up commonly on this exam. So the answer to number 41 is going to be choice 2. Here we go, 42. As I've said, let's read these. Sometimes they don't help. Base your answers to 42 to 40 on the map below. Knowledge of earth science. The map shows a composite of Doppler radar images. Darker standings indicate the precipitation pattern of a large storm system over the eastern U.S. May not really help you other than the dark represents the storm. Most people assume that, but read it anyway. You just kind of should. So here's the image. Here's the question. The surface wind circulation pattern around the center of the storm system is. So you're not really supposed to see it. You're supposed to kind of know it. So the storms are low pressure. You need to know that. I guess I didn't really say that in the question. So any of these storms are low pressure. Low pressure is lousy weather. High pressure is happy weather. And this shows some of the movement around a high pressure is outward and curved clockwise. At a low pressure, it is inward and has a sort of counterclockwise motion. And you always know everything in nature is moving toward a state of equilibrium or balance. And if you have high concentrations and low, it's always going to go from high to low. In this case, this is air pressure, wind, and air movement is about the pressure from high pressure to low pressure. Now, how to remember that? It can be tricky. Look at this phrase. The clock is high, so the clock is high on the wall, and the counter is low. Right? The counter right there is low. So clock is high, counter is low. Therefore, low pressure counterclockwise, high pressure clockwise. Yeah, right? You know who came up with that? Not me. I'm not sure who came up with it, but someone did, and I learned about it, and I like it. Helps you remember it, know it. And this kind of shows how they interact, and this is what you have on a weather map. You have high pressure here, happy weather, nice clear weather, and then the air will move like this, out of a high pressure clockwise into a low pressure counterclockwise. It goes in, then it rises up, and if you have air rising, you have clouds, possible precipitation. So, therefore, the answer here is storm system inward and counterclockwise, choice number 2. 43. Still on this, the best evidence on a weather map to indicate high-speed winds. Wind is the movement of air from areas of high pressure to areas of low pressure. That's what it is. The greater the difference is, the faster the wind will go. Sort of similar to the steeper a hill is, the faster a ball will roll down it. Similar, but not great. So this here is showing air pressures. These are isobars, isolines showing atmospheric pressure, barometric pressure, isobars. And the way we can tell where wind is going to be fast, high-speed winds is where the isobars are closest together. That's where it changes the most for a certain area. So in this area here, they're kind of far apart. So you're not going to have very strong winds here. Here, they're much closer together. I can tell from looking at this map, there can be faster winds here. Okay, so that is essential to this. Therefore, best answer for 43 is choice number 4. 44. As this storm system follows a normal storm track, it will most likely move toward which one of these directions. So here's the center of the storm. How's it going to move over the next day or 2 days? Key thing to know is this. Here's a low pressure. How does it move across the U.S. generally? And it moves in this direction, okay? Like this, eastward or really towards the northeast. Know that. That question gets asked a lot. One way you could look it up if you knew this, in the reference table, you have to know that the U.S. is sort of in this general area here. And look, the general global winds are southwest winds, means they come from the southwest towards the northeast. But they show you here the arrow, so it goes towards the northeast. And those winds are what pushes these highs and low pressures. Therefore, that should help if you need a sort of lifeline on this one. And you can remember this, it's on there. But definitely know that the weather moves usually towards the northeast in this case. Choice 3 for 44. Okay, here we go, 45. Here's some info on it. Base your answers to questions 45 to 48 on the passage and map below and on your knowledge of earth science. The map shows locations of the epicenter of a major earthquake that occurred about 1,700 years ago. Point A represents the location on a tectonic plate boundary. Plates X and Y represent major tectonic plates. The island of Crete, the Anatolian plate, which is a minor tectonic plate, and the Hellenic Trench have been labeled. Arrows indicate relative directions of plate motion. Okay, read it. And here is the passage. Now, before I even read the passage, sometimes, actually, I see it a good amount of times. It says read this, and then there'll be 3 questions after it. None of the questions have to do with the passage. And that messes kids up a lot. On behalf of all teachers and adults, I want to kind of apologize because I know, like in global studies, they're giving you all of these DBQs and stuff, and they're saying your answers have to come out of the reading, and then kids get that in their mind, and they look here and they get totally confused. That does not work that way in this class. Oftentimes, I've seen all 3 questions. They don't reference any of this. It's all some other knowledge or reference table, so be careful. So, scientists have located the geologic fault off the coast of Crete in the Mediterranean Sea that likely shifted, causing a huge earthquake in the year 365 that devastated life and property on Crete. The southwestern coastal region of Crete was uplifted, as evidenced by remains of corals and other sea life now found on land 10 meters above sea level. Scientists measured the age of these corals to verify when this event occurred. This earthquake caused a tsunami that devastated the southern and eastern coast of the Mediterranean Sea. It is estimated that earthquakes along the fault associated with the Hellenic Trench may occur about every 800 years. Okay, let's see what the questions are here. Here's the map. And here's the question. Which type of plate boundary is represented at point A? Where's point A? Point A is there. What's the plate boundary? See, because it shows the arrows of motion. So, just to review, plates moving apart, they're divergent, called divergent plate boundary. When they move together, it's called a convergent plate boundary. And when they do this, sort of slide past each other, it's called the transform plate boundary. You don't have to memorize this because reference table, page 5, the names are given and they're shown at the bottom here. Therefore, it's this kind of motion here, the sliding past. Oh yeah, so it's shown at the bottom. In this case, it is a transform plate boundary, the sliding past. That's 45, choice 3. 46. What are the names of the major tectonic plates X and Y? Okay, this is a little hard to find. Best case, instead of looking around and trying to find the landforms, use the latitude and longitude. So, let's say this is, I'm going to pick on this is 40 degrees north, 35 east is kind of the center-ish here, right? Let's look at this page of the reference table. It's page 5. Tectonic plates. So 40 degrees north is here. Okay, 40 degrees north is here. And then, 35 degrees east. Okay, this is where it gets a little weird because, so 35 degrees east is like in here. So it's in this general area here. Okay, so it's in this area here. And they have the Eurasian plate. And then this is where it gets weird. It doesn't really say the plate here. You gotta wrap around over here and go, the African plate. That's where it gets weird. I hate when any kind of questions on the edges of maps or obscure. I can't think to make that. Are they trying to trick you? Not trying to trick you, just trying to make it challenging, I think. But the answer here is the X is the Eurasian plate and Y is the African plate. It's kind of a weird one. 47. Which two New York State index fossils are most closely related to the corals that were radioactively dated in this study? Gives you some species of fossils that have crazy names. So, closely related to the corals. Let's see. Sometimes I like to go back and look in the readings. It talks about any hints here that may give us what it's related to. And I did look through it. There's nothing there that's going to help you. So you have to know about anything index fossils, fossil related. You probably know this, the centerfold of the reference table. This is what you need to look for. This area here has the different families of species that have lived on Earth. And then you have to look for corals, okay? So you're going to find corals right, so I'm going to zoom in. This is where it says corals. So all those are sort of in the same family as the coral family. So that's where they're getting at. And if you zoom in a little more, corals here, it has some of these species at the bottom that have the letters. So this is T, U, and V. Let's look them up. So go back to the reference table, and those species that have those reference letters are down here. We're going to zoom in, and T, U, and V with these very difficult to pronounce names. And then you want to, now you know this, then you're going to look through your choices and you find which choice has two of these. And the answer, the only one that's going to work, is going to be choice 4 for 47. Another challenging question. 48. Which activity could best prepare residents along the Mediterranean coast to reduce the loss of human life during a future tsunami? Okay, and they have some emergency preparedness things here. So it's good to know which ones they relate to. So I'm going to go through some of these. So for instance, board up windows, that's a hurricane thing. Okay, so know that is a preparation for a hurricane. Remove heavy objects from the walls and homes, that's an earthquake. That's what you do if you live in earthquake country. Plan evacuation routes to higher ground. That's for things like a tsunami or a hurricane as well if you live near the coast. And build reinforced basements That's tornadoes, basements, tornadoes, okay? So with that said, tsunamis right here, plan evacuation routes to higher ground. Therefore, that's the best answer, choice 3 for 48. 49, baby. Let's do this. Base your answers to 49 and 50 on the photograph below and your knowledge of earth science. The photograph shows a sandstone erosional feature that formed near the Grand Canyon in the southwestern United States, and that's it. Notice how it's thin here, not as thin at the top. So here's the question. Which erosional agent is most likely sandblasting this rock formation? The key thing here is this. It is sandblasting. You have to know that sandblasting, that type of erosion is occurring by wind. You have to know that sandblasting is a wind thing. It's the wind picking up sand, blowing it at something, and all of that hardness and the friction of the sand will actually weather and erode the rock that's there. So answer here 49 is number 1, wind. Here we are, last multiple choice, number 50. Woo, here we go. What is the range of grain sizes that are most commonly found in the rock making up this feature? And you know, you could be really stumped on this. I'm going to tell you, you need to go back. Sometimes if you're completely stumped, look at where you could find some sort of clues. And the clue here is this: sandstone. Okay? If you don't know that it's sandstone, you're not going to be able to answer this. But it is sandstone. So basically, what is the size sediments that make up sandstone? We're going to look in the reference table for this on page 7. So that's this. It's the sedimentary rocks, page 7. And then we're going to see sandstone is here. Okay? Has grain size right there. And we're going to zoom in a bit. And it says sand. That's the size range. It's in centimeters, 0.006 to 0.2 centimeters. And then if you look at your choices here, these are your choices. So it's choice number 2 is number 50. Thanks for watching all 50 multiple choice questions. If you watched them all, I'm Mr. Gazda.